Hello, I'm Maia Kelly. I'm the lead developer at Sciences. Today I'm going to be talking about our recently published tool, GlyCombo. GlyCombo is a freely available software tool that's able to rapidly assign monosaccharide compositions to glycan precursor masses. On this slide here, I have a bit of information about how GlyCombo fits into the overall workflow, as well as down at the bottom, I have some technical details on how GlyCombo works. Now here I have some of the information that's exported after a GlyCombo search, as well as some of the information on what we do in the beginning steps of GlyCombo to parse the data from MZML files or just a simple mass list loading. Today I'm going to be focused on giving a quick start tutorial. So I'm going to show how you can use GlyCombo in our example data to quickly run a GlyCombo search. I'll talk about what all of the tabs have as far as options and search parameters, and then show how the run will be performed, as well as some of the results files and parameters files. We're going to start here on the Start tab, and we're going to look at some of our options. We have our input, we have our mass error, reducing end, and derivatization options. Up here in input, there are two options. There is the text in MZML. You can copy and paste a text of your mass list, or you can upload an MZML or text file. For mass error, you have the options of Daltons or parts per million. You also have a variety of reducing end options. For the derivatization, you have native, permethylated, and peracetylated, and then a variety of monosaccharide options up here. We have hexose, hexnec, fucose, new AC, and new GC, and if you toggle any of these, the minimum and maximum buttons will pop up. You can input your numbers for your minimum and maximum for the search parameters that are relevant to your experiment. If you would prefer to use one of our preset settings, there are a variety of here that will populate all of these different monosaccharides. Under our Advanced tab, we have many more monosaccharides that you can add to the search parameters, as well as some adducts and other advanced searching parameters. If you would instead prefer to add a custom monosaccharide, a custom reducing end, or custom adduct, there are options here to input their masses, chemical formula, and ranges as well. And then finally, our next tab is documentation that just has some information about GlyCombo, as well as some of the information for each of the tabs and a link to our publication. But going back to our Start tab, we're going to run an example search. There's this button here that says example, and that's going to pre-populate with a text list of masses, as well as some of the search parameters for these. You can see that these masses have been populated in our text box, as well as a reducing end, derivatization, mass error, and monosaccharides. You'll notice down at the bottom there are a list of monosaccharides that have been submitted or added to our search. So even if you put in some of the monosaccharides from our Advanced tab, they will also populate here in our settings summary, so you can see before you search what your search parameters are. But now we're ready to run, so we can hit the Submit button, and you will see here an option to name your file. I'm just going to name this example file right now, and this is going to be the name for your results CSV file. Now that we've saved the file, GlyCombo will run, and in this case, GlyCombo has finished running in 0.045 seconds, and 16 monosaccharides were identified with our short mass list. In this case, now we can pull up our results. So I'll pull those up right now. And you can see here we have two files. We have our example file, and this is our results right here, the CSV file, as well as something that says parameters. This is our parameters file that includes everything that was set to run, as well as our precursor targets. If you would like to replicate this, you can import this under this button, and it will allow you to rerun this. But let's open up our results. Here are our results, and you can see we have a couple of different columns here. We have composition, observed mass, theoretical mass, and chemical formula. For all of the observed masses, you can see that we have identified a composition for each of these, as well as given a theoretical mass, chemical formula, and then a mass error, which is from the observed mass to theoretical mass, so the error between those two. For this observed mass, you can see there's actually two compositions for this observed mass, And we've included both of those possible compositions as well as their chemical formula and mass error from the theoretical and observed masses. Now, if you'd like to run again, all you need to do is come and hit this reset button and you are ready to run again.